We are going to deal with Lqg control with extended Kalman filter for power systems with unknown time delays. A rotor angle or a load angle or a power angle or torque angle, as it is called by various names, in terms of a synchronous machine, refers to the angle between the stator magnetic field and rotor magnetic field. As everyone might know, the speed of the stator magnetic field is called as rotating magnetic. The speed of the stator magnetic field is called as synchronous speed. The another name that has been assigned to the stator magnetic field is called as rotating magnetic field, because the magnetic field, it has a constant displacement with respect to the reference axis. When it comes to a transmission line, the rotor angle refers to the phase difference that is existing between a three-phase synchronous generated EMF and the voltage of an infinite bus bar to which the generator is connected. An infinite bus bar is the one which maintains a constant voltage and constant frequency throughout its length and breadth. So whenever we are referring to a synchronous machine, it can be either a synchronous generator or it can be a synchronous motor. The rotor angle stability refers to how effective a power system remains in synchronism after being subject. How effective a synchronous machines connected to a power system remains stable irrespective of being subjected to a small or large disturbance. Under steady state condition, or whenever there is no any sort of disturbance, the input mechanical torque and output electromagnetic torque will be the same. Whenever there is a disturbance, the electromagnetic torque suffers a change. In a multi-machine power system, there are two possibilities for a generator. All the generators will be running with the same speed, but if one of the generator runs faster than the other, the generator that is running at a slower speed will transfer its load to the generator which is running at a higher speed. So whenever there is a difference of speed between the two generators, the rotor angle of the faster one increases relatively with respect to the slower one. So in order to bring it back to the same thing, the power system tries to reduce the rotor angle by transferring the load from the slower machine to the faster machine. So whenever there is a disturbance in the electromagnetic torque, there are two types of torque that can be getting affected. One is called as a synchronizing torque, another one is called as a damping torque. So synchronizing torque, it depends upon the rotor angle deviation, whereas the damping torque depends upon the speed. So synchronizing torque is a torque which comes into action whenever there is a deviation between the rotor speed and the stator speed. And it is the torque which is going to act on the shaft of the synchronous machine. So whenever there is a lack of sufficient synchronizing torque, there will be oscillatory instabilities, non-oscillatory or aperiodic instabilities. So damping torque is a torque which is going to be produced whenever due to the currents induced in the damper winding or amortisseur winding of synchronous machine, and its purpose also serves a similar purpose of reducing the deviation of the rotor speed from the synchronous speed. So whenever there is a lack of sufficient damping torque, it results in oscillatory instability. So what do we mean by this instability? Oscillatory instability, non-oscillatory instability refers to increase in the rotor angle, whereas oscillatory stability increase to ever increasing amplitude of the rotor oscillations without getting damped. So these two things, they are mainly affected by the automated voltage regulator. The non-oscillatory instability occurs whenever the AVR is trying to maintain a constant field excitation, and oscillatory instability occurs whenever the AVR is trying to continuously change the field excitation. The field excitation is nothing but the voltage applied to the rotor winding of a synchronous machine. In a synchronous generator, the rotor is subjected to both DC excitation as well as to the prime mover. In synchronous motor, the rotor is subjected only to the excitation. So whenever we are dealing with the rotor, we are having two types of rotor angle stability problems. One is called small distance, another one small disturbance, another one is called large disturbance. So small disturbance occur whenever there is a small changes in the load. So one of the main concern with the power system is small signal disturbances because of its undamped oscillations. So whenever you are dealing with a small signal disturbances, the time of frame which will be considering for analysis purpose generally falls between 10 seconds to 20 seconds. Since rotor is an electromechanical component, rotor oscillations are called as electromechanical oscillations. So what are the different types of rotor oscillations that can occur is local mode oscillations or local plant mode oscillations. The local mode oscillation occurs when the rotors of a generating unit of a single power plant is undergoing severe oscillations when compared to the rotors of the generating units of the remaining portion of the power system. So the frequency range generally falls between 1 Hz to 2 Hz. Inter-area oscillation occurs whenever the just group of generating units in one area are experiencing oscillations when compared to the group of generators present in another different area or a neighboring area. The frequency of oscillation generally falls between 0.1 Hz to 1 Hz. The control mode oscillation generally occurs due to various control equipments that we are employing in a generator, namely exciters, speed governors, HVDC, converters, static volt ampere compensators like this. Torsional vibrations occur whenever there is the whenever rotational component existing in the turbine generator system are experiencing some sporadicity. The changes can be either due to turbine side or in the power grid side. One of the main examples that can be on the turbine side is the failure of the turbine blade. Whereas in case of a power grid, it can be due to sudden turning on of large loads, motor starting or turning off networks. So with said with this paper mainly deals with local mode oscillations and inter-area mode oscillations and how we are going to damp these two oscillations by using a specific technique called as a linear quadrature Gaussian control technique. Thank you.